Not 10,000 light years, not 5,000, 1,560. An invisible thing heavier than 10 suns is circling almost next door, and the night above your house gives away almost nothing. If stories like this are the reason you keep looking up, subscribe now. Stay here for the space mysteries that sound made up, right until the real numbers prove they are not. There is a lot more hiding in this story than one black hole. For a long time, black holes lived in the public mind like giant mouths in space. People imagined them glowing, feeding, tearing stars apart, and making huge, violent messes. That picture is not fully wrong, but it is only the easy version, the loud version, the version we notice first. The truth is stranger, because some black holes are not loud at all. A black hole is what can be left behind after a very big star dies. That star runs out of fuel, its core falls in on itself, and gravity crushes it into something so dense that even light cannot escape. No light means no direct picture, no simple photo, no bright dot you can point to and say, "There it is." That is why black holes are both famous and hard to find at the same time. Most of the black holes we knew first were easy to catch because they were feeding. Gas from a nearby star fell toward them, heated up, and shined in X-rays, a kind of powerful light our eyes cannot see. Those systems are like dark animals standing in a spotlight because the stolen gas gives them away. Astronomers got used to finding black holes by looking for that bright warning sign. But what if a black hole is not eating anything right now? What if it sits there in the dark, cold and quiet, with no glowing gas around it and no dramatic burst of energy? Then the usual search fails, and the black hole becomes almost like a missing piece in the sky. That is the kind astronomers had wanted to find for years. They wanted those quiet black holes for a simple reason. The feeding ones are rare and messy, and their wild behavior can hide the basic truth of what black holes are like in normal life. A quiet black hole tells a cleaner story about how stars die, how gravity rules, and how many of these objects may fill our galaxy. Without that cleaner story, the map of the Milky Way stays incomplete. That search became more serious because of a spacecraft called Gaia. Gaia belongs to the European Space Agency, and its job is not to take pretty pictures first. Its main job is to measure where stars are, how far away they are, and how they move, with shocking accuracy. It is like building the most exact star census humans have ever tried to make. Gaia has watched more than 1 billion stars in the Milky Way. Instead of asking only what shines, it asks how each star drifts, leans, wobbles, and changes its path over time. A star can move oddly if something else is pulling on it, even if that hidden thing gives off no light at all. That makes Gaia perfect for hunting dark objects. Now the story starts to turn. Among huge amounts of Gaia data, astronomers searched for stars that seemed to be dancing with something invisible. Not a planet, not an ordinary star, but something heavy enough to tug a star back and forth in a way that did not make sense at first glance. Out of many strange cases, one stood apart. The team was led by Karim El-Badri and worked with data from Gaia and other telescopes. What they saw was a sun-like star moving as if a heavy partner was circling with it. That unseen partner turned out to be the best case yet for a dormant black hole, a sleeping black hole, one that is not feeding. The object became known as Gaia BH1. Gaia BH1 sits about 1,560 light-years from Earth in the direction of the constellation Ophiuchus. A light-year is the distance light travels in 1 year, so this still means a huge distance beyond normal imagination. But on the scale of our galaxy, which is about 100,000 light-years wide, 1,560 is close. It is cosmic backyard close, not human travel close. The black hole is about 10 times the mass of our Sun. The star beside it is similar to the Sun, and the two go around each other once every 185.6 days. That is a little over half a year, which means this is not some tiny, tight death spiral like people might expect. It is a wide orbit, calm enough that the star is not being ripped apart. Here is the first shock scientists had to face. They expected the nearest black holes they could confirm to be the bright, messy kind that blast out X-rays and practically beg to be noticed. What they actually found was a dark, quiet black hole, much closer than the old record holder, and with no bright feeding disk around it. That gap matters, because it means the sky may be full of black holes our older methods were blind to. Did you expect the nearest known black hole to hide by staying quiet instead of glowing? If that twist caught you off guard, tap like, and tell me in the comments whether dark black holes are scarier or more fascinating to you. And if you want the next surprise before everyone else hears it, subscribe. Finding a hidden black hole is not as easy as spotting one weird wobble and calling it solved. Astronomers had to check whether the unseen object could be something less dramatic, like a faint normal star or a bad reading. So they pulled in follow-up observations from powerful ground telescopes, including Magellan, Gemini North, Keck, and the ESOMPG telescope in Chile. They needed the case to survive every serious challenge. Those telescopes studied the visible star's light in detail. When a star moves toward us, its light shifts a tiny bit one way, and when it moves away, it shifts the other way. This is called the Doppler effect, and it is the same basic idea that changes the sound of a passing siren. By tracking that shift, astronomers can tell how the star moves along our line of sight. Gaia helped with another part of the puzzle. It tracked the star's motion across the sky, not just toward us and away from us. Put those two kinds of motion together, and you get a much stronger picture of the full orbit. That is one reason this discovery held up better than some earlier black hole claims. And that matters because earlier claims had a hard time surviving deeper checks. In the past few years, some supposed nearby dormant black holes made headlines and then started falling apart under new study. The problem was simple. If you measure only part of a star's motion, you can fool yourself. You think you are seeing a black hole, but later the orbit no longer works. Gaia BH1 did not break that way. Its orbit matched the data from different tools, different nights, and different ways of measuring motion. The numbers stayed consistent, which is exactly what scientists want when they are trying not to fool themselves. In science, the strongest discoveries are often the ones that keep saying the same thing after every hard test. Then there was the object's mass. If the hidden companion had really been a normal star with about 10 times the Sun's mass, it would have been bright and obvious. But no second bright star showed up in Gaia data or in those careful follow-up studies. So the invisible object had the mass of a heavy star and the light of nothing. That is almost the perfect fingerprint of a black hole. Pause on that for a second, because this is where the story stops feeling abstract. The nearest known black hole to Earth is not some monster at the edge of the galaxy. It is closer than the next closest known one by a huge margin, less than half the distance of the previous record holder at the time. That is why the discovery felt so immediate and so strange. Still, close in space does not mean dangerous in the way movies teach us to fear. A black hole does not suck everything in from across the galaxy like a giant cosmic vacuum cleaner. If the Sun were somehow replaced by a black hole of the same mass, Earth would still orbit in nearly the same path. The disaster would come from losing sunlight, not from being dragged into a sudden hole. So Gaia BH1 is close enough to matter for science, but nowhere near close enough to threaten Earth. At 1,560 light-years away, it is far beyond any danger to our planet. What makes it important is not fear, but what it reveals about what we have not been seeing. It tells us our neighborhood may contain more hidden objects than we guessed. Did you think closer than expected meant danger? Or did you already know distance in space can sound scarier than it is? Drop your answer in the comments, and hit like if the real story is more interesting than the movie version. If you enjoy science that replaces fear with facts, subscribe and stay with me. But now we reach the part that bothers astronomers in the best way. They did not just find a black hole. They found a black hole in a system that seems hard to explain using the usual story of how such pairs should form. And when nature breaks the script, that is when science gets really exciting. To make a black hole of about 10 solar masses, the original star had to be much larger before it died. Researchers say the parent star may have started with at least 20 times the Sun's mass, maybe more. A star that big does not live long and does not stay tidy. It swells up into a supergiant, a star so bloated it can reach far out into nearby space. That creates a problem. If the black hole's parent star once grew that huge, how did the Sun-like companion survive without being swallowed or badly changed? The current orbit is roughly similar to the Earth-Sun distance, and many models say that should be too close for a normal, peaceful ending. Yet the companion star looks almost normal. This is the expectation versus reality pattern again. Scientists expected a system like this, if it survived at all, to end up much tighter, with the companion star on a smaller orbit and probably badly disturbed. What they actually found was a wider orbit and a star that looks surprisingly ordinary. That gap matters because it says our ideas about binary star evolution are still missing pieces. One idea is that the system did not form the simple way we imagine. Maybe the stars began farther apart inside a crowded star cluster, where close passes from other stars later changed their orbit. Another idea is even stranger. Maybe this was once a three-body system instead of a simple pair. In that version, two massive stars could have orbited close to each other, while the Sun-like star stayed farther out. Those two heavy stars might have become black holes without one huge bloated envelope swallowing the smaller star. If so, Gaia BH1 might even hide not one black hole, but two black holes orbiting each other very tightly. That possibility still needs better future measurements. This is why the discovery is more than a cool fact for headlines. Gaia BH1 is not just a new object on a list. It is a stress test for our models of how stars live together, die, and leave behind dark remnants. When one real system refuses to fit the clean theory, the theory has to bend. And remember, scientists do not think Gaia BH1 is rare because the universe made only one. They think it is rare because it is hard to detect. Some estimates suggest the Milky Way may contain around 100 million stellar black holes made from dead stars. Most would be invisible unless they disturb something around them in just the right way. That means Gaia BH1 may be less like a lone surprise and more like the first streetlight turning on in a dark city. Once one hidden black hole is found this way, it becomes easier to believe many more are waiting in the data. The discovery changes the question from, do nearby quiet black holes exist, to, how many have we missed? That is a very different kind of mystery. Right now, that mystery is still active. Astronomers are still combing through Gaia measurements, still testing odd star motions, still trying to separate real black holes from false alarms. The search did not end when Gaia BH1 was announced. In a way, that was the starting gun. The Gaia team expected later data releases to be a goldmine for this kind of work. Better processing, longer time coverage, and more careful checks should reveal more systems that were too hard to prove before. Once you know what pattern to look for, the sky starts speaking more clearly. But sometimes it speaks with an even bigger surprise than the first one. So here comes the next turn, and this one raises the stakes again. In 2024, scientists working with Gaia data announced another nearby dormant black hole called Gaia BH3. It was not closer than Gaia BH1, but in another way, it was even harder to believe. Gaia BH3 is about 1,926 light-years away in the constellation Aquila. That makes it the second closest known black hole to Earth. But distance was not the part that stunned people most. Its mass was the real shock. Did you see that coming? That the second nearest quiet black hole would also rewrite the weight record? If that kind of twist is exactly why you love space stories, leave a like, tell me which reveal hit harder so far, and subscribe. Because the numbers get even stranger from here. Most known stellar black holes in our galaxy are around 10 times the mass of the Sun. Even Cygnus X1, a famous heavyweight found earlier, is around 21 solar masses. So astronomers had a rough expectation for what a Milky Way black hole should look like. Then Gaia BH3 arrived and smashed that comfort zone. Gaia BH3 has a mass of about 33 suns. That made it the most massive stellar black hole known in the Milky Way when it was announced. Before this, black holes that heavy had mostly shown up through gravitational wave events in far more distant space. Now one of that class seemed to be sitting relatively nearby, hiding in our own galaxy. Again, what scientists expected and what they found did not match. They expected the biggest stellar black holes in our galaxy to be rarer and harder to pin down close to home. What they actually found was a sleeping giant less than 2,000 light-years away. That matters because it connects nearby astronomy with the black hole masses seen in distant cosmic collisions. Gaia BH3 also came with a strange companion. The visible star orbiting it is an old giant star, and the gap between the two is about 16 times the Earth-Sun distance. That is a wide orbit, which is one reason the black hole is not feeding in a bright, obvious way. It is there, heavy and dark, while the companion circles at a safer distance. There is another clue hidden in that companion star. It is very poor in heavy elements, which means it formed long ago from simpler material. In astronomy, metals means all elements heavier than hydrogen and helium, even things like oxygen and iron. A metal-poor star is like a fossil from the young galaxy. That detail matters more than it sounds. Some theories say very massive black holes can form more easily from stars that have few heavy elements. Such stars lose less mass in strong stellar winds, so more of them stays together until the final collapse. In simple words, the star can die heavier, and the black hole it leaves behind can be heavier too. So Gaia BH3 did not just add a new object to the map, it gave real support to an idea many scientists had been using to explain big black holes seen in gravitational wave detections. Those distant mergers were telling us heavy black holes exist. Gaia BH3 said yes, and one route to making them may be right here in our own galaxy's past. Then the story gets even more human, in a strange way. The companion star of Gaia BH3 seems to come from the galactic halo, a looser, older part of the Milky Way. It may have belonged to a smaller galaxy or a globular cluster swallowed by our galaxy more than 8 billion years ago. So this system may carry the memory of an ancient cosmic collision. Scientists also noticed something else unusual. The companion star does not seem clearly polluted by material blasted out when the massive parent star died. That raises a new question. Did the black hole and the visible star really form together, or did the black hole capture this companion later? Now step back and look at what is happening right now, not just what happened once. Astronomers are no longer dealing with one odd nearby black hole. They now have more than one dormant black hole found through Gaia, and two of them are surprisingly close in galactic terms. That changes the feeling of the whole search. Before, hidden black holes near Earth were mostly something people guessed should exist. Now they are measured systems with names, masses, distances, orbits, and puzzles attached to them. That shift is important. A mystery gets more powerful when it stops being a theory and starts being an address on a map. And yet the biggest lesson may be about what we still do not know. Gaia BH1 was the closest known black hole and was hard to explain. Gaia BH3 was the second closest known black hole and was much heavier than expected. The universe did not answer one question and go quiet. It answered with two surprises at once. First, our cosmic neighborhood can hide black holes that are quiet and easy to miss. Second, some of those black holes may force us to rethink how giant stars lose mass, die, and keep companions. That is why this story feels unfinished in the best possible way. What do you think is more shocking? That a black hole can sit this close without glowing, or that one nearby black hole weighs 33 suns? Tell me in the comments, and if you like stories where each answer creates a bigger mystery, hit like and subscribe. Your guess might say a lot about which part of space feels strangest to you. A lot of people hear all this and ask the next obvious question. Could there be a black hole even closer to Earth than Gaia BH1? The honest answer is probably yes. Not confirmed yet, but very likely out there somewhere in the Milky Way. That does not mean one is lurking just outside the solar system. It means our tools are getting good enough to expose dark objects that stayed hidden for ages. If finding one quiet nearby black hole suggests many more exist, then the closest known one today may not stay the closest known one forever. The record could fall again. And if it does, that will not automatically be bad news. Space is huge, and even a nearby black hole in astronomy is often unimaginably far away in human terms. The main effect of such a discovery would be on our understanding, not on our safety. It would redraw the secret map of the dark Milky Way. This is also a good moment to kill one stubborn myth. Black holes do not roam around like giant cosmic drains, sucking up stars at random from enormous distances. Gravity follows rules. A black hole with the mass of a star pulls from far away, much like a star of the same mass would. So if a black hole replaced the Sun without changing the mass, Earth would not suddenly spiral inward. We would keep orbiting, but life would fail because sunlight and heat would be gone. That is a scary thought, but it is a different kind of scary. It is not the movie version of instant cosmic swallowing. What really makes nearby dormant black holes important is how quiet normal space can be. A star can move through the sky with a tiny wobble, and that wobble can be the only clue that a dark remnant sits beside it. No bright flash, no giant warning sign, no monster mouth in a colorful nebula, just math, patience, and a star behaving a little oddly. There is something almost emotional about that. The universe is not only dramatic when it explodes, sometimes it is most dramatic when it whispers. A tiny shift in a star's path can reveal the grave of a giant star that died millions or billions of years ago. And that brings this story back to you. When you step outside at night, the stars can look peaceful and simple, almost unchanging. But that calm view is partly an illusion created by distance and by our limited eyes. Behind that quiet pattern are objects so dense and dark that they can hide in plain sight. A black hole closer to Earth than anyone expected is not just a cool fact for trivia. It is a reminder that even our local part of the galaxy is still not fully known. We have not finished the map. We may not even know which nearby stars are traveling with invisible partners yet. That matters because human curiosity grows through these moments. Every time we think the neighborhood is mostly understood, a new object appears and proves the map still has blank spaces. Those blank spaces are not failures, they are invitations. They invite better telescopes, better models, better questions, and a little more humility. Gaia BH1 tells us quiet black holes can hide nearby. Gaia BH3 tells us some nearby black holes can be far heavier than we thought our galaxy usually makes. Together, they say the dark side of the Milky Way is still full of unfinished business. And maybe that is the real thrill in this whole story. Not fear of being swallowed, not the simple shock of a big number, but the feeling that the sky above us still keeps secrets close, even now, even after our science, even after mapping more than 1 billion stars. One day, there may be a new announcement, another star with a wobble, another invisible partner, another record broken, maybe even closer, maybe even stranger. Maybe one that forces astronomers to rewrite a chapter they thought was stable. Until then, Gaia BH1 remains the nearest known black hole to Earth, and Gaia BH3 remains one of the strongest warnings against getting too comfortable. Nature does not care what we expect. It only does what the evidence says it does, and the evidence keeps getting weirder. So when you hear that a black hole was found closer to Earth than anyone expected, the most important word is not black hole. It is expected. Because expectation is what the universe loves to break. That is how discovery feels from the inside. If you want more real space stories that sound impossible until the data lands, subscribe and turn on notifications so you do not miss the next one. And tell me in the comments this exact question. Do you think Gaia BH1 stays the closest known black hole for long, or does another hidden one beat it soon? If this story stuck in your mind, share it with someone who still thinks black holes only show up when they are feeding. Thanks for watching, and I am glad you were here for this one.